Right, welcome back. There's still a few things that I want to talk to you about on the grade 11 section. Let's just quickly do it. Here, a substance that can act as both an acid and a base is called an ampholyte. And one example of that is water. Water is able to donate a proton. It can also be able to receive a proton. So in that way, when it donates, it's an acid. When it receives, it's a base. And acids that can donate more than one proton or only one proton, we call them monoprotic acids. Acids like HCl, HNO3. Now, those that can donate more than one proton are called polyprotic acids. Okay. Now, coming to grade 12, chemical equilibrium. And here what I have, it's a question that we're going to use to learn something about chemical equilibrium, finding equilibrium concentrations in a chemical equilibrium until the end of this lesson. Now, listen carefully. Here, we're looking at a situation given to us here. We are told that a mixture of 5 moles of hydrogen gas and 6 moles of I2 gas or iodine gas are sealed in that volume container, 2 cubic decimeters. Equilibrium is reached at 500 degrees Celsius. Okay, the balanced chemical equation for the reaction is, and that will be given to us, is this one here, H2 plus I2, giving us 2HI. Now, 4 moles of HI gas were found at equilibrium. Calculate the concentrations of hydrogen gas and iodine gas at equilibrium. Now, remember what we have been doing, but let's just have a look at something quickly. If we are to find equilibrium concentration, we need to come up with a table, or even if we don't come up with a table, but the main thing is we need to know initial moles. In other words, how much are we given at the beginning? Okay, available reactant in terms of moles there. And we also need to know during that process of the reaction, how many moles reacted from our reactants and how many moles were formed for our products there. The number of moles that we have from the reactants that have been used up and the number of moles that have been formed. And finally, we then find the equilibrium moles as the number of moles that of the reactants that remained, that were not involved in the reaction, and the number of moles of products formed. And from there, we can then use the volume to find our concentrations. Now, in our case here, we are told that we are starting with 5 mole H2 and 6 mole I2 and 4 mole of HI formed at equilibrium. Now, let's try and put that into our table here. So if here I've got my H2, okay, so let me write it down here because you can't see it up there, I2, and I've got my HI there. When I balance this, I would have a 2 there. This is my balanced chemical equation. Okay, so let me leave it that way. In the beginning, I'm told that I start with 5 moles here and 6 moles there. And at the beginning, there was nothing there. Mole reacted. How do I find that? I'm told at equilibrium, I've got moles here. Okay? I've got 4 moles here that reacted. That were formed of HI. Here, I need to know how much of that has reacted and how much of that has reacted. If I've got 4 moles here, from my equation here, I will be able to say, look, the ratio is such that 1 mole of this will lead to the formation of 2 there. And 1 mole of this will also lead to the formation of 2 moles of HI. Now, if I've got 4 moles HI at equilibrium, how much of this must have reacted? These ones, I2 is always half of what HI is going to be. So it means that if I've got 2 there, these minus 2, this 2 must have reacted, so I put it as minus 2 there because it means it is gone there. So minus 2 would have produced the plus 4 there. So now it will be 5 minus 2 for mole at equilibrium for hydrogen, and that will be 3. 6 minus 2, that will be 4. That has remained unreacted. Now concentrations at equilibrium, concentration is number of moles over volume. Okay, so this should be equal to 3 moles over what? 2, and 3 and 4 moles here over 2, and this one is 4 over 2. And from here then I can find my equilibrium concentrations. Okay, and what will those be? This will be 3 divided by 2, it will be 1,5 mole per cubic decimeter. And we're gonna finish off this in the next section.